In the last 3 videos of the series, we discussed incrementality, causality, and also made an introduction to the practice of MMM while answering some frequently asked questions about MMM. In this video and the next, we'll see how we can adopt some advanced modeling approaches to combine incrementality and causality to a set of techniques which we refer to as Causal MMM. It's highly recommended that you revisit the videos of incrementality and causality at this point, if needed, to refresh your memory of these concepts. If you take away just one thing from those videos, it has to be this. Marketing measurements is a causal reasoning process to understand the true incrementality of all the marketing initiatives. By now, we already know that MMM is the most scalable incrementality system. It could be used to get your first set of incrementality reads based on certain assumptions. A good MMM system should also offer its users certain support in terms of how they could easily verify and trust MMM results, while at the same time being transparent of its limitations in terms of signal or data weaknesses, multicollinearity issues, and all the other assumptions of transformations that were incorporated into it. But what about causality? Is MMM also a good causal inference system? There are broadly two approaches adopted to make MMM causal. These are model calibration with incrementality tests and adopting causal AI-based algorithms as the primary approach to model and infer treatment effects. One way of doing this is by using structural causal modeling. In this video, we will talk about the first approach, that is model calibration. And in the next video, we will talk about structural causal modeling, which is one of the most popular causal AI-based approaches to measure cause and effect. So let us first discuss model calibration. Remember this triangle? We touched upon this briefly in the first video of the series, while introducing the concept of unified marketing measurements. Here, let us focus on the edge between marketing mix modeling and incrementality experiments, and let us understand this handshake or orchestration that is happening between them. As you can see, this is a two-way relationship. MMM is complementing incrementality experiments, and in return, MMM is enriched by it. What is the exact mechanism at play here? When you create your MMM models, the first set of insights that you see is limited by two things, which are number one, nature and availability of data. Number two, assumptions incorporated into the model, primarily during the random hyperparameter optimization steps. The first part of this handshake is where MMM generates relevant experiment hypotheses. Here, MMM uses the nature of the data to inform the marketers about the important and right experiments that need to be run, so as to be more confident about the true incrementality of those variables. The data limitations are primarily of three types. Type 1, if some variables are underrepresented or sparse, MMM models could end up undercrediting them and or also be less confident about their contribution to the business. Type 2, if a variable do not have enough variations, that is, if you have similar budget outflows to, say, TV commercials week after week without a lot of variations, then the model might not be able to understand the impact of change in outcome with respect to the change in TV spend. Type 3, multicollinearity. If you have input variables that are moving in tandem with each other, that is, they have very high positive correlation between them, then the model might not truly differentiate one from the other. Though the model could give each of the variables distinct credit, the true inference that's possible for such cases is only for the combined effect and not the individual incremental contribution. These data limitations, though limits our confidence on MMM inferred incrementality for such variables, are very important inputs for hypothesis generation. They can inform and augment marketers' wisdom of the right tests that need focus. An important point to note here is that experimentation is a time-consuming and rigorous process. If the experiments are not run with proper randomization and sufficient control, its results become insignificant, irrelevant, or outright erroneous. We'll discuss more on the right approaches to design and deploy experiments in future videos. It's important that your marketing organization invests its bandwidth in the most relevant tests. MMM can help you arrive at those hypotheses. The second part of the orchestration relationship between incrementality experiments and MMM is where incrementality experiments generated lift or incrementality numbers based on practices such as geo-testing, time testing, or lift studies are used to guide models' hyperparameter optimization process during the model training or model calibration step. Now let's take a step back here and let us define model calibration before we move further. In statistics, model calibration refers to the process of adjusting a model's predicted probabilities to better reflect the true likelihood of an event or outcome. This means a model that predicts a 90% probability of an event should, on average, be correct 90% of the time for similar predictions. In marketing context, however, this is a slightly difficult definition to adopt. We do not have many repetitions of a real-world event. We only have one. This is also related to what is known as the fundamental problem of causal inference. That is, counterfactuals are not observable in the real world. More on that later. The definition of calibration that's closer to what's more intuitive to the marketing context is this. Calibration is the process of adjusting model parameters to match experimental data. It involves finding a set of model parameter values that enable the model to map the relationship between the inputs and the output of a given dataset. This is from the paper by Carlos F. Lopez et al. In 2021 titled Current Opinion in Systems Biology. This paper is from the domain of biology, but it is very relevant to the way we should think about calibration in the context of unified marketing measurements. Now let us look at the applied side of calibration. In an earlier video where we introduced MMM, we discussed that the hyperparameter optimization process is essentially a random process where we pick various parameter values such as alpha and gamma for saturation and shape and scale parameters for Adstock from within a permitted range of hyperparameters and apply regression on top of these transformed values. While doing this, we also optimize for some objectives. In this process, we run many tens of thousands of iterations, and in each iteration, we try to minimize some measure of goodness of it as dictated by the objective function. The calibration process, when applied along with regular training of the model, gives us one additional objective to be mindful of while performing hyperparameter optimization. Let us take this example so as to simplify this concept. Here, the initial run of MMM has understood the temporal values of incremental ROAS of Facebook prospecting as shown in the chart. It fluctuates between 3x and 2x initially, while dropping to 2.5 to 1.5x, and then falling close to 1x in the recent times, with some periods of time where it was even understood to have contributed less than 1x in incremental ROAS. But let us say we have some test results for Facebook prospecting from a very well-run geo-test for October of 2024, which suggested incremental ROAS of Facebook prospecting to be about 2x within a range of say 1.8 to 2.2x at 95% confidence. If we retrain the model by incorporating the calibration for October 2024, model hyperparameter selection will happen in such a way as to minimize the distance between model inferred incrementality and the actual causal incrementality for that period, that is October 2024 in this case, for Facebook prospecting variable. The outcome after calibration could look something like this. Here we can see that incremental ROAS of the period after October 2024 is now pulled in the direction of incremental results from the experiment, that is closer to 2x from the earlier average of a little over 1x. However, we can see here that MMM still does not completely agree with experiments. It does not fix its coefficients in accordance with experiments, and it's very important that it should not. And this disagreement is not a bug, it's a very important feature of calibration, at least in the context of unified marketing measurements. There are a few reasons for this. Reason 1, MMM is still limited by and based on the data that it has. It does not have a way to align with experiment results based on the data that it has. All it does is to pick the hyperparameters so as to minimize its disagreement or distance with the incremental results from experiments. Reason number 2, MMM has the concept of Adstock effect. Some variables could have immediate, while some can have short-term decay or lag, and some will have long-term decay or lag. Experiments always measure the impact within a testing window. It does not have any implicit way to understand the long-term impact. So the 2x incremental ROAS that experiment reports for October for Facebook prospecting is mostly an underreported case if we consider the lag effect of that spend, which will only be realized after some more days into the future. While the 1.8x that the calibrated model gives for this period has also incorporated some Adstock effect from the previous period and is also able to extrapolate some impact to the future besides the 1.8x of the immediate effect that it reports using the shape of Adstock transformation. Reason number 3, MMM and experiments are fundamentally different techniques. We need not force fit one into another. We should be able to have a hybrid approach of leveraging both the insights for driving right outcomes. This is where unified measurements as a practice and solution gains a lot of relevance. Unified measurement platform is not just a place to run MMM and experiments. It's also a place to bring them together through the handshake we just discussed. Most importantly, unified measurement should also offer marketers a very robust decision-making layer built on top of this orchestration or handshake in such a way that they can pick and choose which measurement method should be trusted for which channel. That is, if they trust experiment for Facebook prospecting, they should be able to adopt that for Facebook prospecting. While for all the other channels and tactics, they should be able to continue to rely on MMM models or any other technique. So from everything that we have learned so far, calibration should be thought of as a method to bring causal insights to MMM for some course correction or guidance during hyperparameter selection. Before we move on, one very important point about Lifesight's approach to calibration. At Lifesight, we have a couple of different ways in which calibration gets applied. We refer to this as fine and coarse calibration. The example that we went through just now was that of fine calibration, where we were trying to minimize the disagreement between modeled and actual incrementality of the tested variables for a specific time window. In coarse calibration, Lifesight applies the calibration window for the entire date range for which the data is available for that variable. This is very similar to setting a prior as in the Bayesian process. This brings us to the second step to make MMM truly causal, which is structural causal modeling. Though we introduced model calibration as a way to make MMM causal, we saw that it just gives some direction to the regression-based MMM in how to pick its hyperparameters for certain time periods. It cannot force regression models to agree with experiments completely, and it does not resolve some of the fundamental fundamental flaws and limitations of regression-based approaches to inference. In the next part, we will discuss the shortcomings of regular ML models and how to overcome these limitations with causal AI. We will discuss the adoption of structural causal models as a better algorithmic framework for building causal MMM.